Sometimes equations can be summarized to focus on the principal substances and ions that are involved in a reaction. These are called ionic equations. During some chemical reactions, not all atoms will actually change. These species that don't change, they are the same at the end of the reaction as they were when the reaction started, are called spectator ions. To write an ionic equation, we want to remove these spectator ions to see exactly what took place in the reaction. To do this, there are a few steps that we will follow. Starting with our balanced equation, we would first separate any substance that is aqueous into its ions. Substances which are aqueous have the state symbol AQ. A state symbol is a subscript which tells us the condition each chemical involved in the reaction mixture. An S represents a solid, an L represents a liquid, G represents a gas, and AQ means a substance is aqueous, or it means it has been dissolved in water. When ionic compounds are dissolved in water, the ions actually separate from each other. So our first step is to write these ions separately. Two substances in this equation are aqueous, potassium bromide and potassium chloride. Just a reminder, the name of these ionic substances are just the names of the ions combined, which means potassium bromide is made up of the potassium ion and the bromide ion. Failing that, just remember that the symbol for each new element starts with a capital letter. So we want to split potassium bromide right there. We also need to remember that once the equation is balanced, and we do start with a balanced equation, that the coefficient is for both of the atoms. Once I separate potassium bromide into its ions, that means I have 2 potassium ions and I have 2 bromide ions. I have 2 potassium ions on the product side and 2 chloride ions. Anything that exists as a solid, liquid, or gas, you'll have to write them back exactly the same. Just a reminder, aqueous means a substance is dissolved in water, and these substances would have their ions being separated. Once it's a solid, liquid, or a gas, these are written exactly how they are given. So we're going to write Cl2 and Br2. So our first step is complete. And the second step says we should cross out all the spectator ions. Remember, spectator ions look exactly the same on the reactant and on the product side. They don't change. So on the reactant side, we're starting with 2 potassium ions, 2K+. We're going to check on the product side to see if we're seeing 2K+. If we're seeing the same thing, that means it didn't change, and that is a spectator ion, so we'll cross it out. Next, we have 2 bromide ions, so 2Br-, and we're looking on the product side to see if we see 2Br-, which we don't. We're seeing Br2, a liquid. So there was a change. It means that that bromide ion actually reacted. It took part in the reaction. Next, we have Cl2. We're going to look at the product side to see if we're seeing Cl2. We're not. We see 2Cl-, 2 chloride ions. And because, again, this is written differently, it tells me that chlorine actually took part in the reaction. So the only thing that did not change was the potassium ions. And we're going to just cross out those spectator ions. The final step is to write anything that we didn't cross out, all the things that remain, we're going to write them down, and that will be our ionic equation. So our ionic equation says 2 bromide ions plus a chlorine molecule forms two chloride ions and the bromine. Now we put our state symbols back. And that would be our ionic equation. The difference between our molecular equation and our ionic equation. The molecular equation shows us all the atoms from all the species, while the ionic equation shows us only those elements that actually react. Let's do a second example. Here we have sodium carbonate plus hydrochloric acid forms sodium chloride, water, and carbon dioxide. We need to start with our balanced equation. Let's go ahead and do that. We have two sodium atoms on our reactant side. We only have one on the product side, so I know I need to put a 2 in front of the entire formula. I have one carbon, one carbon. I have 3 oxygens. I have 1 plus 2, 3 oxygens. I have 1 hydrogen on the reactant side, but I have 2 on the product side, which means I need to put a number in front of HCl. So I'll go ahead and put a 2 there, which means I now have 2 hydrogen on both sides. But remember that 2 also goes for the chlorine. So now I have 2 chlorines on the reactant side, and I also have 2 chlorines on the product side. So that means this equation is now balanced. Once we have our balanced equation, I can go ahead, identify anything that is aqueous, and I'm going to separate it into its ions. So first we have sodium carbonate, sodium plus carbonate. This says I have 2 sodium ions. Remember that these little subscripts in the formula tells us how many atoms we have of that. And I have 1 carbonate ion. Remember the carbonate ion is CO3. So it doesn't mean that we have 3 of the carbonate ions. Look back at your list of all your polyatomic ions, and the carbonate ion is just CO3, 2 minus. We have hydrochloric acid. That 2 in front says I have 2 hydrogen ions, and I have 2 chloride ions. Sodium chloride, so I have 2 sodium ions, 2 chloride ions. Water is a liquid, so I have to write that the H2O. Remember, we don't separate anything that's a solid, liquid, or gas. Carbon dioxide is a gas, so I have to write CO2. Next, I'm going to look at both sides of my equation, both sides of the arrow, to see if there are any species that are exactly the same. I have 2 sodium ions on the reactant side. I have 2 sodium ions on the product, so we cross that out. Carbonate, CO3, 2 minus. I'm not seeing it on the product side. 2H plus. I'm not seeing it on the product side. 2Cl minus. I'm seeing 2Cl minus on the product side. We have now crossed out all our spectator ions. These did not change. They're not really taking part in the reaction. So to write our net ionic equation, anything we didn't cross, we're going to write them back. So the ionic equation would be carbonate ion plus my hydrogen ions form water and carbon dioxide. And I'm going to go ahead and put my state symbols in. So you might be wondering if you're always going to have state symbols, or if you're going to have to know them eventually. Yes, you will have to know them eventually, but some things are fairly common, We know carbon dioxide, we know it's something that we exhale, it must be a gas. We know oxygen is a gas. We know other gases in our environment, in the atmosphere around us. Nitrogen is a gas. We know that metals are solid. There's one exception. Mercury is an unmetal, that's a liquid at room temperature. We know water is a liquid. It can change state, but then that don't have to state the conditions. If they say solid water, we know that it must be not solid. Or I guess they wouldn't say solid water, they would say ice. Or if they say steam, we know that steam is when water is a gas. So some of these things are very common. We just have to think about our actual environment. And once we move on to acids, bases, and salts, so we are going to learn some more about the solubility rules of ionic compounds, and that will tell us whether a substance will be aqueous or not.